Alright, let's first talk about what we did recently. We just explored that some trinomial, tri means three terms, happen to be perfect. Not all though, some. If you have the last number half of the middle number squared. So that's the condition. So my notebook needs to be opened again, sorry. So if this last number n is the middle number's half squared, don't forget to square, then we call it a perfect square trinomial. Again, these are all perfect square trinomials because the last number is square of the middle number. 10, take half, 5, squared 25, perfect. 9 is half of minus 6, 3, minus 3, square it. Yeah, this is a perfect square trinomial, but most trinomials are not, so you can't do anything about them, alright? So what we are going to do today is we are going to put this, what we learned, perfect square trinomials into work, and we will set them into 0 and start solving them. And it's a 4-step procedure. Okay, so you need to follow these steps one by one, and that's what I'm gonna do here. Solving means in the end you will get n equals a number. Most possibly you will get two different n values, whatever the variable is. For this question as well, you will get y equals something, y equals something. That's when you stop, okay? But first, we need to prepare this question. Step 1. Let's read step 1. We need to divide both sides by a. What is a? What do you think a is here? A is a number, but where is it hiding?
Would it be the 10?
Nope, it's not 10. That's b. This is b. This is C. A is
in front of the n squared.
Yep, it's in front of the n squared. That's 1. If A is 1, you don't have to do step 1. You're lucky. So this question is considered a little bit easier because you don't have to do step 1. In this question though, A is 9. Yeah, we will definitely do step 1 here on this question. Okay, here you're good. No step 1. Step 2. Isolate the variable terms. What are the variable terms here? What are they? N squared and 10n. I need to see them alone. These must be alone. So everything besides these terms must go away. So what do you see next to this guy? 21. You need to cancel that 21 by subtracting 21 from both sides. Okay, you see I emptied out this spot, but I still kept some space here. I wonder why. It's gone. There's still some space for it. That's for step 3. So far step 1 and step 3 is trivial, right? Any questions? Now we're in step 3. We will do completing the square part. It's almost what we did yesterday. You are going to find out the magic number here that's gonna come and make these three terms trinomial a perfect square like yesterday. You guys remember you tried to find n's, the last number, to make this a perfect square, and you even did it in quiz? Yeah, you're gonna do it now for this question. What is the magic number to show up here? It's gonna make 1, 2, 3 terms a perfect one. What's the trick? You take this number,
5.
take half of it, 5, and put it right here as 25. Square it. Well, can you just add a number to one side of an equation like that? Can you? Are you allowed to do that? Can you just put one side any number you wish? No, that's not fair. It's a scale balance. It's a thin balance between left and right. You can't just put weight to the left and ignore the right side. You must do whatever you're doing on the left side to the right side as well. So take that number 25, to this side as well. Okay? Makes sense? Okay. Now, just like yesterday you did, once you have a, this is perfect, right? I know it's perfect because I chose this 25 in such a way that it's a perfect square. Since it's perfect, it must turn into a square. But what square do you think it's going to turn into? I believe one part will be n. What is the number?
5, 5.
Yeah, it's always this number you found with the sign. Half of 10 is positive 5. So we put positive 5 here. If this was a negative number like yesterday, you would put a negative number there. Does it make sense?
Is that step 4?
I'm still step 3. I'm still in step 3. Step 3 has several sub-steps. I did this here. This one was here. Now I'm factoring this trinomial into square. I'm factoring it into square. Okay? And minus 25 plus 20, minus 21 plus 25 makes 4. Now step 3 is over. We're done. So this was step 3. Step 3. This was step 2. Step 2. And step 2 we never done it. Okay? Alright, step 4 is now you have a perfect packed square on the left and a number on the right. This is, and now look at this question. Put this in your mind, memorize. Look, this question is now looks almost, no, this question. You just add 5 to the other side. Aren't they similar now? Something square, set it into number. So we just flipped the question into one of the easy type questions. Stuff squared and set it into number. So to be able to solve for n, you need to first get rid of the square. And how do we get rid of a square? Yeah, we do square root property. So we do square root property. You basically take square root of both sides, right? And get n plus 5 on the left. And square root of 4 is 2. Are we done? Oh, we just need to get rid of 5 next, right? Are we done now?
Plus 3.
Yeah, this is a mistake. Most of the time you guys just take a look at the positive side. Square root property yesterday says when you take square root of both sides, the question separates into 2 parts actually. Positive and negative of this guy. There is a plus minus in front of this number. So you need to take the negative root 4 as well, which is negative 2. So you separate plus 2 and minus 2 into 2 questions and do the similar work for this side as well and get another value for n. Usually in these questions you will obtain 2 solutions. Usually I'm saying, but sometimes you may end up with a single one as well. Rarely though. Is this clear? Again, if you have a number in front, you divide, which is not the case on this question because it's 1.
Could you have avoided all of that because it's a perfect square trinomial? Could you have just skipped all of that, moved 21 over to the other side, and then wrote n plus 5 squared?
Okay. This is what you mean, right? So you moved 21 to the other side and made minus 21?
Yeah.
So you're saying this is n plus 5 squared? Like that?
Yeah. Would that be that way?
No, because when I FOIL n plus 5, it's not these 2 terms. n times n is n squared, n times 5 is 5n, 5 times n is 5n, 5 times 5 is 25.
Is that bad?
Yeah, look, you have only two terms here, you're missing the third term. Okay? So we need to make up for that third term by adding 25 to both sides. That's what we did here. Always, a perfect square requires three terms. If you have only two, it's not sufficient. You need to get that third term computed from the middle term. Okay? Any more questions on this? Both -3 and -7 are the answers. You can test these results by entering into n, submit these answers values to n, and compute this and make sure it's 0 before testing. Okay? Any more questions? Alright, now this one has a solid A in front. We need to do step 1 first, which says divide both sides by A, which is 9. So this 9 will divide the first number, middle number, and the third number on the left. All of them must be divided by 9. This is easy. 9 over 9 is 1. Yeah, first term is 1. The second one is 24 over 9. The third one is 80 over 9. How about 0 over 9? What is 0 over 9? That's 0. The right side is okay. Alright, are we through? Are we done with step 1? Have we finished dividing? Please simplify as much as possible. I see something common between 24 and 9. There is a common factor. You can cancel. What is it? You can reduce 24 over 9 by dividing both sides by 3. How about 80 and 9? Can you reduce them? No. 80 doesn't have any common factor with 9. 80 has 2, 5, a lot of 2's and 5, but 9 has only 2 factors, and 3 and 3, nothing common, they won't reduce. Okay, I'm okay with that. So this is y squared 8 over 3y. It's really important that you reduce these guys, okay? I mean, it's not a mistake if you leave it like that, but it's just gonna make your life easier in the next steps. This was step 1. Step 1 is over. Any questions? I divided both sides and reduced. Any questions? Let's start step 2. Isolate the variable terms. Mark the variable terms here and get rid of everything next to this box. What is it? 80 over 9. How do I get rid of it? I subtract 80 over 9 from both sides. Cancel, cancel. Okay, so we have y squared minus 8 over 3y. Let's go underneath. Y squared minus 8 over 3y. Space, this is gone to the other side. And step 2 is over. I just want to leave a space here because there is going to be a perfect number filling that space. This is a useless number. I get out of my way. Get it out of my way. I'm going to pick a perfect one, and with that perfect number, 1, 2, 3 terms will combine into a perfect square. Okay? So what is that number gonna be, guys? What number do you guys need to add both sides so this 3 term can make a perfect square? Anyone? Come on, somebody needs to name it. How do I find the number here? It's gonna turn this thing into a square. It's like yesterday. What is this number? You need to obtain from here to there. 16 over 9. Let's check. We take half of this. Half. So how do you guys get a half of a fraction? Minus 8 over 3. Divide by 2. You either combine these two denominators, 3 and 2, and make 8 over 6, or if there is a cancellation in numerators, you do that. There is. So that is minus 4/3. Half of 8 is 4. That's it. If the top does not divide by 2, you need to combine 2 and 3, make 6. 8 over 6, and 8 over 6 still reduce to 4/3. Okay, I got 4/3 here, half. Well, you don't take it here. You square this and put it to question mark space. What is square of negative number? It's positive all the time. 4 times 4 is 16. 3 times 3 is 9. Yep, 16 over 9 is the right answer. So I put that filler here to both sides. 16 over 9. 16 over 9. So that I'm 100% sure this can be made into square with a magic number next to it. What is that number? It's already on the screen. You don't have to compute again. You already found it actually. What's that?
16 over 9?
No, it's not 16 over 9. 16 over 9 is square of it. Whatever this number is, its square is 16 over 9. It's always this half of the middle number comes here, okay? Half the middle number. So it is minus 4/3, minus 4/3. Okay? How about these two? We add them because they share the common denominator. And what is minus 80 plus 16? Negative 64. Step 3 is over. I added both sides. I added both sides with half the middle number, half the middle number squared. 16 over 9 added. And I factored this trinomial into a square. I'm through with step 3. Here comes the last step. I'm gonna do it on this side. This is the part you find the solution. So take this to here. You're gonna get rid of the square now. And guess how we do this? You take square root of both sides, but don't forget to split the right side, the number side, as plus and minus into 2 directions. Again, y minus 4/3 is first positive option, second the negative option. Can you follow? I split it as plus, I split it as minus. Okay. Next, I will first try to simplify this, cure this radical. Why do I need to cure it? Because it has a negative. So I need to bring this negative out. That negative out, not as negative. You can't move negative out as a minus sign. You can move it out as a symbol called I. So this is I 64/9, and this is negative I 64/9. Next, can you save 64/9 from this jail? Can you?
Yeah.
Yes. What is square root of 64? What is square root of 9? So you can save them. 64 is 8 square, 9 is 3 square. Both pay the fee to the guard and they come out. So you actually have 8/3 I here. And same deal on the other side. 8/3 I. But we like i's after the number. Okay, I'm gonna move them right after the number i's. Next, we have one more thing to fix. This 4/3 must cancel out from the left side, because we need to get y by itself. I need to get y by itself, so I'm adding opposite of this number to both sides, so we can have these two canceled. Okay, so we have 8/3 I plus 4/3, or y can be minus 8/3 I 4/3.
Four on the left. 4I.
Which one?
We're going to turn 4I on the left. Because it turned into 12/3 simplified to 4.
Oh, you're saying we can add these two? Like 12? 8 plus
I'm
4?
asking, can we?
No. Because 8 and I are not separable. You have 8I together here. Like 8x. 8x and 4. Can you add 4 and 8x? No, they're not like. But this is called a complex number. This is the real part. This is the imaginary part. We usually like the real part in front. So I want to put 4/3 first and 8/3 I next. This is just more appropriate. But both answers are okay. Look, these only differ by a sign. You can even combine these two results into one as 4/3 plus minus 8/3 i's, because they are the same, exact same, except they're conjugates. Their signs in the middle flipped. So you can put them together as plus minus and make one big solution. Are we clear? It's a pretty long question. Okay, let me repeat from the beginning. Okay, we started off by dividing both sides. I did simplify as much as I can, and I got rid of the number and moved it to the right because this was a useless number. It's not making this a perfect square. So I removed it to the other side and picked my own number, added both sides, and then square root both sides, get plus and minus. When I did that, I happened to have a negative sign inside the jail, so we cured them out as i's, plus minus i's, and those numbers 64/9 turned into perfect 8 and 3. We just flipped the terms and left y alone and got a combined result. You can put these two separately or combine, it's up to you, but it's just most efficient if you put them into one symbol like plus minus. Otherwise you need to type in the same thing twice. And you can even insert that I to the top, 8i, instead of separate I on the end. Or you can combine these denominators as well. What I mean is, if you wish, since they have the same denominator, you can write your answer like this. Okay, you can combine the denominators. Alright, looks like we're done with number 10. There is only one question left here, and it looks different. However, it's easier than number 10. This is like number 9, the previous question before 10. However, there's something weird with this question. What is weird? It looks different than this, and that this question is different than these two last questions, because yeah, this is factored form. We need to first distribute this out. Okay, that's one thing. It makes this. What else is weird? There is no zero. We like seeing all three on the left. However, yeah, can you fix that and move minus 8 to the left side? Yes, you can. But the question is, am I gonna do that? Do you think I should be doing this? I'm moving it? Why not? Because we are going to do that in step 2 anyways. If you have a number next to 4x, you need to move it to the other side anyways, and this is already moved to the other side. So this question is even easier than, more convenient than number 9, because they already moved 8 to the other side. Okay? So step 1 is, why did I skip step 1? Because it says divide both sides by the number in front of x squared. There is no number to divide, so I skipped this one. I skipped step 2 as well, because step 2 says if there is a number here, move it to the other side, but they already did. They already have the number on the other side. X's are isolated. So step 1 and 2 have already been done. All we need to do is take some space before the equal sign, right here, and compute that number, please. Alright, this is easy. You should be telling us, what is it? 4. Do you all agree? We take half. Always do this. Show this work so you can be justified, okay? Yes, when I square it, square 2, it's 4, but I need to add it to both sides. Okay? Now we are going to collapse this into a square, and this is going to make a 12. Alright, you tell me what comes inside these parentheses. It's x plus 2. This blue number, that's why I always show this work, because I need to see this number and move it here, plus 2.
That's negative 4 then?
Negative?
Would that be negative 4 on the right? Because it's plus 4, so you have to subtract it.
No. I'm adding plus 4 this side. Why you should be subtracting
it at the same time?
Yeah, you need to put it in the same. Just think of scales, right? Scale. Left side of the scale, right side. You need to put the same weight to both sides. You're putting 4 pounds of weight to the left. You need to put 4 pounds of weight to the right. Okay? Or 4 apples to left group, 4 apples to right group. Okay? We only subtract things if you need to cancel, move a number to the other side. Okay, what is next after this? We break this into 2 groups, with one with the plus, square root. You take square root of both sides, remember, right? And put plus and minus sign. You put the plus sign to the left, a minus sign to the right. And I need to get x all the way by itself. Now how do I subtract these two? I can't. So I put minus 2, positive root 12 together. And these two cancel. Minus 2, minus 12. Oh, I noticed these are exactly the same except the sign in the middle. So can I combine them back into one single notation? Plus minus root 12. Okay, one minor adjustment required here. I left out. What is it? What else can you do? You can simplify your answer better. What did I miss?
Break down 12 and 3 and 2.
Yeah. See if there are any jailbreakers here in 12. Are there any? 12 is 4, 3. 4 is 2, 2. So it's double 2 and a 3. You see 2 is breaking jail. Two is gone. History, it's out here. 3 is still in though. So this is the best optimal answer to go into the answer box. But I'm just curious if it's gonna accept this one. I wanna try the first one first. It didn't, because it wants us to simplify as much as possible. So I will take 2 out and then 3 in. Yep, it's like this one better. Okay, so here's the lesson we got. You need to simplify, and if you have a big number in the JL, see if there are factors that comes out. Any questions? No? Alright, then I wish you all